Okay, so that was a roundup of all the different instance types, and again, a huge number. So how do you pick? Well, let me just first of all say that you're not locked into anything with AWS. Okay, so if you don't know for sure what you need, pick a general purpose, all right, or pick a CPU optimizer, whatever you think. But then when you launch your application on it, monitor and see if you've got the right type, and then you could change later on. That's a beautiful thing about AWS. Okay, so I had a question come in. Can general purpose be used for data warehouse? Yeah, it certainly can, but you don't know if it's going to be the most optimum one. And as I was saying, you could try general purpose and then try some other ones and then see which gives you the best performance efficiency and then make your decision there. Another question, can you please answer how can we share private AMI within a group? Okay, when you create the AMI, you actually specify the users that you want to share it with. Next question, if we are talking Linux operating system, how come this, oh, we already answered that question. Okay, yep. Okay, let's go back to now what an instance role is. Okay, so an instance role is the permissions policy for an EC2 instance that's going to run my application. Now, I'm not going to move my developer credentials up there. Instead, I'm going to create a role for my EC2 instance and assign a permissions policy that matches what my application needs. Then when I launch my EC2 instance, I have it assume that role, and then when I copy my application onto it, it will use the permissions policy associated with that role to be able to access S3 or DynamoDB or whatever service that it needs. So there is a set of credentials that have to be used to make the API calls, right? But they are going to be automatically copied into the instance's metadata. So when I just assume the role at launch, it's going to contact a service known as STS and get a set of credentials and store it in the metadata. But here's the good thing. It will actually expire those credentials frequently and keep replacing them on the fly. So it'll always get a fresh set of credentials and expire the old ones. So there's very low risk in using an instance role because credentials are temporary as opposed to things like my developer credentials, which were permanent and long-term. These are very short-term. So they're a lot safer to use on a server. Okay, so that's why we want to use instance roles and not your own developer credentials or credentials that you copy into there, and definitely not the master account credentials. Okay, so let me do a little demo here and show you some stuff on how you can create an instance role. Okay, let me go back to my console here. And I'm going to go under services and IAM. Okay, now before I create the role, I want to create a policy for it. So I'm going to create a permissions policy. Now this time, instead of just selecting a canned one, I'm actually going to show you how to create your own permissions policy. And there's a really easy way to do this. You just click on create policy, and then you could choose to copy an AWS one and make it your own and edit it. You could use a wizard known as the policy generator, or you could just type the text for a permissions policy. Now, before you choose that option, I have to warn you, it's JavaScript object notation. It's JSON. So if you're really happy with curly brace and all that stuff, and you want to just type it in, you can do it. It's fine for simple policies, but you know why else you would use that? Is let's say you're copying a permissions policy from somewhere else. So if you're just copying the JSON and you want to paste it, you could just copy and paste into the create your own policy section. Okay, but let me show you the policy generator because this is probably the most common one that you're going to use. It's pretty simple. You set effect of either allow or deny for all of these different service operations. Now, everything is implicitly denied. So if you don't allow it, it's already going to be denied. So you don't have to specify denies all the time if you want. You can just specify the things that you want allowed, and that's good enough for most applications. All right, so I'm going to go here now and pick a service. Now, I know that my demo application is going to need to access S3 buckets, so I'm going to pick S3 for the service. Now, when I do that, this next box is going to be filtered to the available operations that can be done on S3, okay? So I'm going to pick some that I know my application is going to need. Get bucket location, get object, let's see what else, list all my buckets, and list bucket, and I need a bunch of put object stuff. So I'm going to do put object and the ACL because I'm going to need that, and I might want my application to at some point do these other ones, so I'm going to give all the put object permissions, okay? Okay, so now the next part of the permissions policy is to actually say what buckets this is referring to. So we specify the resource. Now, you should go very fine-grained with this and say just this particular bucket or something like that if you know your application always is going to use a particular bucket. But let me show you how you can make it a little more general just in case you're not actually sure and you don't want to limit your application to just one bucket. For example, my application, it listed all my buckets. So obviously it has to be able to see all those buckets. So when you define a resource for your permissions policy, you have to use something called Amazon Resource Notation, ARN. So it always starts with ARN and then a colon, and then AWS, then colon, and then the name of the service, which is S3. Now the next part of this is supposed to be the region and the account number, but we can actually skip that. And the reason why we can skip that, only for S3 by the way, is because our bucket names tell AWS this information. So just by going to a particular bucket, that already is going to designate the account in the region, so we can skip it. Now I'm going to make this for all of my S3 buckets, so I'm just going to put a wildcard asterisk. Okay. Anytime you specify an asterisk, that means wildcard from that point on. Okay. So I'm going to click on Add Statement. Right. You can see all of the things that I'm adding to here. Get object, get bucket location, list all my buckets, list object. Okay, that sounds pretty good. I'm going to click Next Step. Okay. There is the JSON right there, and it was generated for me by the policy generator. Okay, I'm going to give it a name. It's a little bit more useful than the one that they created. So I'm going to call this S3 upload policy. And you should put a description on permissions policies because you don't want to necessarily have to read complicated JSON all the time. So you can say used by S3 upload demo app. That's what I'll put in this case. Okay. And then also down below here, there's a way to validate your policy. So if you make a mistake on it, right, if you edit it and make a mistake, and you click on valid policy, it'll tell you there's an error. So then you can fix it, right, and then click on validate policy, and then you could actually create the policy. Okay, so now I've got a policy, but where is it? Well, to see your own policies, you want to filter this list based upon customer managed. And now you can see my policies that I've created here. Here's the one that I just created. Okay, so I created the policy. Now I need to create the role for the EC2 instance that's going to use this policy. So I'm going to click on roles and then create new role, right? Now this is going to be for an EC2 instance, so I have to pick EC2 from here. Okay, so I select that. I choose my policy for the role. Again, customer managed, S3 upload policy, click on next step, and then give it a role name. And in this case, I'm going to call it S3 upload policy. I'll just leave the description, and then I'm just going to click next step and then create role. Okay, that's it. So now I've created the role. It's right here. S3 upload policy. Okay, let's go back to the slides for some more stuff. All right, so we've got the role set up now, and the next thing is to discuss user data. Now, user data is bootstrapping code that is going to run, sorry, I mean to do that, bootstrapping code that is going to run one time when the instance first launches. Okay, and this is going to be to do basically configuration of the instance, such as install a platform that's not already on the AMI, like maybe PHP or Apache web server, update security patches, like do update distribution software packages, install security patches, stuff like that. I could use it to download custom applications from a source code repository or an S3 bucket. I could install agents like monitoring agents or things like that. And I could just execute command lines in my bootstrapping script, right? But remember, this is for configuration, so it only runs one time. So if you have something go on and you want to change your user data and run it again, you can't run it again on an instance that's already been created. This is only for the first time an instance launches. Now here's an example, right? For Linux, it's basically a bash shell script, right? And if you've done anything on Linux before, you probably recognize what this does. It just does a yum update, right? And then it's installing Apache and then PHP, right? It's enabling Apache to start up automatically, and then it's starting it. It's switching to the var www.html directory and is downloading my demo application from my bucket, okay? So then it's unzipping it. So this is now gonna download the latest version of my application and install it, okay? So that's a pretty straightforward user data script. In addition to that, there's another way that you can generate, sorry, I didn't mean to click that. Another way that you can execute user data, and it's a different format where basically you just list the stuff that you want to have happen. In this case, it's a cloud config format. You basically just say that you want to update to your repo and upgrade what packages you want to install, and then you can run commands like that. And it's a little bit easier in case you're not a developer to be able to use cloud config. All right, for Windows, you have your choice of PowerShell or just batch scripts, right? And you can see basically very simple things. It's just installing IIS and web management tools on the left there. And then other things, you're setting up Windows remote management on the other ones. Again, these are just typical scripts that you might use for user data. So just remember, on Windows, it's got to be a batch program or PowerShell. Okay, so now the last thing we're going to need is a key pair, right? And I've been saying this a couple times that you have to have a key pair, and the reason is because the way Amazon controls access to log into your instances is through the use of key pairs. Now, they're a pair of keys that consist of a public part and a private part. And on a Linux instance, what they do is they take the public key and they copy it to a directory on the EC2 instance when it launches automatically. That directory is .ssh authorized keys, okay? The private part of the key, the user who's going to connect has to have that saved locally on their desktop, okay? When they make an SSH connection, they have to provide the private key and it has to match the public key on the server, then they're able to SSH. Okay. Now for Windows, we don't use SSH, we use remote desktop. Okay. So what happens is Amazon will create an administrator user on the instance and generate a random password, but they won't give you the password until you provide the private key that matches the public key associated with the instance. So you provide the private key and then it decrypts the administrator password for you. Then you could remote desktop into the Windows server because now you have the administrator password. So the key pairs are used to give you that initial connection into the EC2 instances with the default users. Okay. So speaking of connecting to the instances, for Linux, we're going to SSH, right? And so basically you just have to provide the private key and then you log in as EC2 user for most of the Linux distributions. However, for Ubuntu, you log in as Ubuntu user, but most of the other ones, it's EC2 user, right? If you're going to be doing this from a Windows desktop, you need to get a SSH client because they don't have one built into the terminal window like Mac does. So you need to get something like PuTTY, which is a free one that you can download at putty.org. Okay. And again, for connecting to Windows instances, you're going to use remote desktop, right? And you're going to get the administrator password before you log into it. Okay, I have a demo ready to go, but why don't we take a little break here again? Since we've been running over an hour again, let's take a break till about, let's see, how about 25 after the hour?